Hello students, welcome to Nilachal Polytechnic. We are studying about the control chart. Control chart is the graphical representation of the data collected from the manufacturing area. That may be dimensional analysis, that may be defect calculation. And in control chart, we can find out that whether the process is under control or not, whether the products are acceptable or rejectable one. The control chart, the concept of control chart can be understood by using this concept like a torrent lathe is producing 100 numbers of spindles and these are having diameter 2 centimeter. After they are made in the diameters were measured. Certain measured value lie quite close to the desired dimension. Some are known as your mean diameter, mean value, whereas other diameter. Values are quite far from the mean value because the fact that variation inherent in all process. Therefore, in product dimension, we have to draw a figure to show these features. It is necessary to accept those pieces which fall under a set of specified tolerance limit or control limit. From this example, it is clear that we are having two types of control limit. One is upper control limit, another is lower control limit. There is a tolerance limit, means the product dimension is 40 mm plus or minus 0.002. If the accuracy of product is to be checked, then that will be maximum limit 40.002 and another is your 39.98, that is the another control limit, that is lower limit for the dimension. So, if the diameter of the product in such a way that it lies in between the maximum limit and minimum limit, then the product is to be called as acceptable. That is, upper limit is 40.02, lower limit is 39.98. That is the range of diameter in between those. The diameter of spindle are selected or acceptable. If there is not and is below from the tolerance limit or above the tolerance limit, then the product are rejectable. So by utilizing the different graphs, we can find out that what are the different use of control charts. So there are two types of control chart. One is variable control chart, another is your attribute control chart. Variable control chart means where you are going to measure the quantities like dimensions measured, what is the RPM of the shaft, what is the diameter of the shaft, length of the shaft, if there is any complicated part, what is the thickness, what is the angle. So these are known as a variable data. Those quantities or those characteristics of the part where we are going to collect the information about the dimensional accuracy, we are going to use two types of chart. One is your X bar chart and another is your R chart. X bar chart means X mean chart or mean according to the mean average or mean or average value, we are going to draw the X bar chart. And another is your R chart. R chart means that is the range chart. Range chart means that is in a sample size we are having a sample having maximum diameter, another is minimum diameter. So that is according to the range of any sample size, we are going to establish a relationship and we have to plot the graph for the R bar. So we are having two types of variable chart, X bar chart, R chart and S chart. Another, the data or information are collected regarding the defects, regarding the defects, and defects may be in terms of painting, appearance, any porous in the product, any defect in the product, there is performance ability of the product, there may be defects in the product like welding defects, casting defects, and there is in cracking the glass material. So if the informations are related to that of the appearance or that is your defects, there are two types of charts are used. One is your defectives, fraction of defectives will be collected. Another is the number of defects will be collected. So the defective pieces are divided into equal subdivided or different subgroup size. In case of variable chart, sample size is constant, but in case of attribute chart, the sample size is not constant. We have to find out the mean sample size. So the two types of defective fraction of defective charts are used. One is a P chart, another is a NP chart. Similarly, to calculate the defective, there may be different sample size or maybe equal number of sample size. We are going to use C chart and U chart. Let's come to the selection of control chart. Basically, we are going to have two types of data. One is your continuous data, another is your discrete data. Continuous data means we are going to measure the data. Those data is related to the dimension like length, width, thickness, diameter, RPM, angle measurement. So those parts which are related to the measurement of quantities are known as your continuous data. Discrete data means these data are variable and we are going to collect the defects. So there may be fraction of defect we have to calculate. We maybe calculate the number of defects in a particular assembly. So in a defective fraction of defective, we are having two, the sample size may be constant, may be variable. Similarly, number of defects calculation in defective chart where you may have that variable nature or maybe constant nature. So we are going to study about that. There are two types of charts where attribute chart and attribute is known as your discrete data and a variable chart is known as your continuous data. We are going to use X bar and R chart as variable chart, and for defective chart it is P chart, R chart and your C chart, U chart. Thank you.